The Johnstone Supply Company Cafferty Group presents VRV System Operation. This system is in 100% heating mode. The refrigerant leaves the compressor as a superheated high-pressure vapor. Its first stop is the oil separator. The oil separator is a spiral device that uses centrifugal force to separate the oil from the refrigerant as it leaves the compressor. Then it returns the oil back to the compressor where it belongs. When the oil leaves the oil separator, it passes through a filter and then a solenoid valve. The solenoid valve is activated or opened when the system goes into oil recovery mode. Oil recovery mode is triggered by the system controller when the compressor runs a specific amount of time at lower frequencies, which is where the oil separator is the least effective. The oil then passes through a capillary tube to remove any liquid refrigerant that could be trapped in the oil so that it doesn't damage the compressor. As a refrigerant leaves the oil separator, it too passes through a filter or bullet strainer on its way to its first stop, which is a tube-in-tube heat exchanger or subcooling coil. From the tube-in-tube heat exchanger, the refrigerant travels to its first section of outdoor coil. Notice that this particular diagram has 3 four-way valves. Also notice that the outdoor unit heat exchanger is divided into 3 separate compartments. So in this type of system, the 4-way valves not only control the mode of operation, but they also control the capacity of the system by regulating the amount of refrigerant through the outdoor heat exchangers. So the system only uses the amount of outdoor heat exchanger needed. In this example, the system is in 100% heating mode. So the 4-way valves will direct the refrigerant to both the outdoor heat exchanger, where one small section will be used to cool the inverter board, and it will direct the rest of the high-pressure vapor to the indoor units, where they will be used for heating. You will notice the presence of several refrigerant filters in this system, making a clean refrigerant piping installation even more important. As the refrigerant passes through the outdoor heat exchanger, it is subcooled into a liquid. The smallest section of this heat exchanger, which is the bottom in this case, first passes through a heat sink to cool the inverter section of the control board. After the subcooled liquid refrigerant leaves the heat sink, it passes through an electronic expansion valve, which in this case is pulsed wide open so it is not metering. The refrigerant then travels to a spot where it meets up with the liquid refrigerant coming back from the indoor units. The rest of the high-pressure vapor leaving the compressor is routed to the 4-way valve leading to the high-pressure line going inside to the branch selector box, then routed to the indoor units that are calling for heat. The branch selector is available in either a single, 1 indoor unit connected to 1 branch selector box, or multi, up to 12 indoor units connected to 1 branch selector. In this example, there is an individual branch selector box for each indoor unit. As the superheated vapor refrigerant enters the branch selector on the high pressure line, it passes through an electronic expansion valve which is pulsed wide open and not metering. It allows the refrigerant to flow freely to the indoor heat exchanger. As the superheated vapor travels through the heat exchanger, it is subcooled into a liquid, and the heat removed from the refrigerant is given off to the space. The liquid refrigerant leaving the indoor heat exchanger then travels back through the branch selector on the liquid line and is returned to the outdoor unit. When the refrigerant re-enters the outdoor unit on the liquid line, it is routed through a series of check valves to the liquid receiver. The liquid refrigerant leaving the receiver meets up with the liquid refrigerant from the 3rd compartment of the heat exchanger and is then routed to the electronic expansion valves just ahead of the other 2 compartments in the outdoor heat exchanger. The electronic expansion valves meter the refrigerant, causing a pressure drop and changing the state of the refrigerant from a liquid to a low-pressure saturated vapor. As the refrigerant passes through the outdoor heat exchanger, it is absorbing heat from the outdoor air and changing the state of the refrigerant to a superheated suction gas. The suction gas leaving the outdoor heat exchanger is routed through two four-way valves to the suction line just ahead of the accumulator. The low-pressure gas then leaves the accumulator and travels back to the compressor to start this process over again. Here is an example of the same process through a multi-zone version of the branch selector box. You can see everything works exactly the same, except there is one selector box for multiple indoor units. Thank you for joining us on this journey through a VRV system. We hope you found this helpful and informative. If you would like more information, please contact your local Johnstone Supply Cafferty Group office.